Hey everyone, welcome back to Cruise class. In today's lesson, we'll be looking at the different trig ratios, the trigonometrical ratios. You might hear it as the trigonometry ratios, or just for short, the trig ratios. Now, these are some ratios that we use to apply to different trig questions and trig problems and problems that we can use trigonometry to solve in general. Now, these ratios are very important, and it's good to understand the basis of them and how we can use them to solve simple trig questions. Now, we have to first understand the basic trig ratios come from the right-angled triangle. Here we have a right-angled triangle A, B, and C. As you can see the right angle here, we have an angle here, phi, we have an angle here, theta. And the hypotenuse is running from A to B. Now, the hypotenuse is a term that is only given when we're dealing with right-angled triangles. The hypotenuse is the longest side of the right-angled triangle, and the hypotenuse will always be opposite to the right angle. Opposite meaning it is right across from the right angle. As you can see, the right angle is here. Hypotenuse line is here, so it is directly across from the right angle. Now, when we're dealing with the trig ratios, we are dealing with respect to a specific angle. Now, in this case, let's look at theta, the angle right here. If we're dealing with angle theta, first thing we have to understand is that the lines and the names of the lines will be different regarding the different angles we're dealing with. So in theta, one thing that doesn't change, for example, A, B is the hypotenuse at all times, as we can see here. Now if we're dealing with theta, AC would be the adjacent side to angle theta. Adjacent simply meaning it's right beside it. So if theta is the angle, AC is the line that is right beside it. The other line that is beside it is the hypotenuse, and that already has a category of its own. So therefore, the other angle beside it must be the adjacent. Now, BC, in this case, would be the opposite line to the angle theta. So for angle theta, once more, the hypotenuse is here, it doesn't change. AC would be adjacent to theta, and BC would be opposite to theta. Now, if we're dealing with angle phi, the hypotenuse will be AB. AC, however, would be the opposite to phi, while BC would be the adjacent to phi, because BC is the one that is right beside the angle phi. So, same thing as right here. Angle phi, AB would be the hypotenuse, AC would be the opposite, and BC would be the adjacent. So the point of this is just to compare how, with respect to a specific angle, the adjacent and the opposite will be different. But the hypotenuse will always remain the same, because the hypotenuse is simply the longest side of the right angle triangle. Now, these are the trig ratios. Now, if an angle is represented by theta, as we see here, the sine of that angle must be the opposite side divided by the hypotenuse. The cosine of that angle will be the adjacent side over the hypotenuse. And the tangent of that angle will be the opposite side over the adjacent side. These are the three main trig ratios. These are what we will use to apply to different trig questions and solve them. Now, a simple way to remember them, when I was growing up, I learned this. It's called so, ka, toa. Now, so meaning the sine is equal to the opposite over the hypotenuse. Ka means cosine is equal to the adjacent over the hypotenuse. And toa meaning the tangent is equal to the opposite over the adjacent side. So this is not necessarily a rule, but it's just a little simple fun way of remembering what the different trig ratios are. So, in summary, trig ratios deal with the three different sides of a right angle triangle, and the three trig ratios of necessity are the sine, the cosine, and the tangent ratios. Now, this has been introduction to the trig ratios.